Yeah, so my talk's on keeping secrets secret. Sort of been several years in the making. I sort of have a thing for finding secrets that are not where they're meant to be. So yeah, my name's Olly. You can find me everywhere at Olly the Ninja, including GitLab. Nick wants you to know that GitHub isn't the only place you can store source code.
That's right.
And yeah, crazy. And I'm a security engineer at Control Plane. Been working there for a couple of months now. We do. Is it going to change slides? It will change slides. Yeah, so we're a security consultancy. We do a lot of cloud stuff. We're based in the UK, and we only opened a New Zealand office this year. So there's 3 of us in New Zealand, and the rest of us are in the UK. So everyone's like, "Oh, who are you? How long have you been around?" Like, "Oh, we've only been around for a couple of months in New Zealand." Yeah, we do stuff with government clients and lots of regulated industries around container security and a lot of Kubernetes, because that seems to be something that people have trouble securing. So yeah. But more about this talk. So I'm going to talk a little bit about why keeping secrets secret matters. Hopefully, being at a security meetup, you already have an inkling of why that might be important, and sort of the high-level goals of secret management, and then a little bit about the sort of process that I see teams go through to improve their secrets management processes. It's definitely not a one-shot. Yep, we got that box ticked. Move on to something else, and hopefully you'll have a better understanding of the considerations that you might need to think about around secrets management, some of the tools and resources that you can use to make your stuff better, and improve security, because that's what OWASP is all about. So what are secrets? There's lots of different types of secrets, but specifically I want to talk about machine-to-machine communication. So, your application talking to a database, or different applications talking to each other via an API or something. Not talking about users authenticating to systems, because that's a whole nother thing. So usually it might be usernames and passwords, it might be TLS certificates, mutual TLS, API keys, tokens, whatever you call them. If it's 2 different systems talking to each other, that's what we're talking about. So I'm not talking about humans and how they authenticate, but I will say that you should be using long and strong passwords and putting them in password managers and using 2-factor authentication. And CERT has some beautiful imagery that you can use when you're talking about that to people. Yeah, so we're not going to focus on the humans. Why is secret management important? So there's secrets, which means that we probably shouldn't be not everyone should have access to them, right? Sort of in the name, but there's a few things that tell us why it's important. One of them, being in an OWASP meetup, is that the OWASP top 10 has 2 things in it. The OWASP top 10, have we covered the OWASP top 10 today? Does anyone not know what the OWASP top 10 is? Because we are at an OWASP meetup. Okay, so the OWASP top 10 is the top 10 vulnerabilities in web applications as defined by a group of people that went and talked to companies all around the world and security companies all around the world, and were like, hey, what are the most common vulnerabilities that you see? And they compile a list of the top 10 vulnerabilities, and then they do a whole bunch of other stuff under the OWASP project, but that's the headline thing. And there's 2 of them: cryptographic failures and identification and authentication failures, that sort of relate to making sure that your secrets stay secret. OWASP also does a list of proactive controls, which are things that you can put in to try and stop breaches from happening in the first place. And there's a bunch of them that relate to keeping your secret secret as well. If you're more of a MITRE fan, MITRE is a framework for vulnerabilities and the defenses against those vulnerabilities. They have a thing called common weakness enumeration, which does what it says on the tin. It lists a whole bunch of common weaknesses in applications. And they also have a bunch that talk about credential management failures. In fact, they have a whole category for it. So a bunch of people that are a bunch smarter than me have put lists together that include the fact that secrets management is important for security. Cool. Just to take a step back and think about information security in general, in my mind, the sort of 3 goals that we have in information security are to reduce the likelihood that we get breached or that one of our systems gets breached, to reduce the impact if it does happen, and to have some stuff so that when it does happen, we can figure out what happened and make sure it doesn't happen again. When we're talking about secret management specifically, I've taken the OWASP, more OWASP stuff. I've taken the OWASP cheat sheet for secrets management. OWASP has this great project called the Cheat Sheet Project, where they have cheat sheets on like every security related topic you can think of, and they've made lists of all the things that you need to consider. So if you ever like, I don't know anything about mobile application security, but someone just asked me what they should think about for security for their new app, there's a cheat sheet which you can look at and then be like, oh, have you thought about it? Have you thought about look like you know more than you do, and learn at the same time. So yeah, I constantly refer back to the different OWASP resources. But what I've done is I've sort of broken them down into 3 categories because there's a lot of stuff on the secrets management cheat sheet. So the first category is foundational stuff. So stuff that it's not really negotiable. Like I think it's stuff that we can probably agree needs to be done. And it's also stuff that doesn't really, there is an endpoint. There is like a point where you can say, yes, I have done this with all my things. So one of them is encrypting all the secrets. When some people will argue that not all data needs to be encrypted and disk encryption doesn't matter for servers or whatever the case may be. But when we're talking about secrets, encrypting them when they're stored and encrypting them when they're transiting between systems is super important, and we should be doing it everywhere. The other one, which isn't just important for secrets management, but is important for everything, is backups. Making sure that, especially secrets, we think about we're going to be using secrets on all our systems so that they can communicate with each other and know who each other are. Then if we're going to manage them somehow centrally, everything else is relying on that central management or however you choose to manage them. So we need to make sure that that's backed up and that we can restore it, because your backups are only as good as the last time you checked that you can actually restore from the backup. And the third one is have policies. And I'm not talking about like policies that your auditors are going to check that you have. I mean, things that are plain English, things that development teams can look at and understand what the expectations are of the systems that they're building. Because otherwise it's really hard to say, hey, you're not really doing this right. And they're like, well, how am I meant to know what to do? Give them some guidelines, give people some expectations of what you want them to do. And then, yeah, the earlier you can get that, the better. So the next ones are the core goals of secrets management. First one, as I already touched on, if you're going to have some central place that all of your systems are going to have their secrets stored centrally, you better make sure that it's always available, because if your secrets management system goes down, all of your other applications aren't going to be able to talk to each other, right? So super important that we can access it all the time. Centralize and stabilize. So as a security person, we're probably interested in things like, are people rotating their database keys regularly? You know, are they generating database keys, database passwords that are like summer 2018? Yes, we are rotating that every 90 days, but somehow it still says 2018. So if you have them in a central place, it makes it a lot easier to sort of go through and check that they're being rotated, things like that. Also makes it easier if you want to change them, because you know that there's one central place that they're stored that you can change them and that'll go out everywhere. And the other one is stable. I've certainly been in organizations where we've changed the way we want everyone to do things, and quite quite legitimately, some of the teams are like, oh, well, 3 months ago, security told us that we had to change everything, and now you're telling us to change it again. Like, should we even do it? Because it's going to take us 3 months. Then you're going to tell us to change it again. So making sure that it's something that, doesn't change too often, so that people feel like this is something that they can invest time and effort into, and it's going to pay off over a long period. It's pretty important too. It might not be that you have like just one place. You might have some cloud stuff and some on-prem stuff. It might be that you need 2 different ways of doing things for those 2 different systems. But if there's 101 ways of doing things and every team's doing it a different way, then you're going to really struggle. Did it turn over? Did I turn it over? And the last one is least privilege access, which is also a general security thing, right? But there's 2 aspects to it. One is that all of our different applications, say you have 2 applications and they both need to talk to the database server because they both have a database. They need separate users with separate passwords to get into those separate databases, so that one day when one of the applications gets breached, you know which application it was that got breached and accessed the database, all of that. And then on the other hand, they should only have access to the things that they need access to. I've been the person that rotated application A's database password, and then 3 hours later had application B's team standing at my desk going, why can't our application talk to the database? And it turns out it's because they were using application A's database access to talk to application B's database. Like, well, lots of things are going wrong to make this. So now they all have separate users and they only have access to their databases. Cool. And the final one is, still not 100% happy with the name of this, but these goals are like, you really need to focus on the other ones first. Once you got them down pat, then you can start working on this stuff. It's also something that if you're a small team and you only have one application, you only have a couple of credentials, it might not be as important as if you're a large organization. But they're definitely still important things that you should work towards. The first one is auditing, like knowing when someone last accessed credentials. It's really useful. When they were last rotated, who has access to them. It's really useful and comes in handy in a lot of ways, not just when you have a breach, but also when you're just trying to figure out, like, is this database user still being used? Has anyone like logged in there recently? Yeah, so auditing is super useful, having logs for things. The other one is being able to do the lifecycle management centrally. So being able to have your secrets management thing be able to create passwords for you automatically every time you have a new application that needs to access something. Being able to rotate those from a central place so that you don't have to like figure out which application is that. Okay, so I have to go to that application and update its secrets, and then I have to figure out which database server is talking. So if you can do it from a central point, that makes life a lot easier. And the same with revocation. If you find that someone accidentally committed their keys to GitLab or GitHub or any of the other source code related things, pasting, having one central place that you can go and say, revoke this key, it's been compromised, rather than having to figure out which system it is, which team's responsible and stuff. Yeah, makes that management a lot easier. And the final one, which is sort of related, is automating those processes. So not just being able to rotate database credentials centrally, but being able to do it automatically every 90 days. So you don't have to go in every 90 days and go through all the applications and rotate passwords. Yeah, cool. So that's a summary of those goals. It's available in the OWASP secret management cheat sheet. I have a link at the end, but you can also just Google it and it'll come up. But yeah, I've tried to group them nicely. So the other thing I said I was going to talk about was sort of how teams tend to improve their secrets management. It's definitely not a it can be tricky, especially if you're dealing with applications that have been around for a while. They have certain ways that they expect things to work. So it can be tricky to like modernize how they get their secrets. But inevitably, it gets triggered by someone having hard-coded secrets in their application, and someone finds it in their Git repo. That person's often me, and then has to go have a conversation with someone about how we should be doing secrets management, and try and get them doing things a bit better. The reason I picked raw chicken is because it's kind of like raw chicken. You kind of don't want it lying around. Yeah. So, I mean, talk about there's other ways that people store secrets that are also not good, but generally they boil down to hard-coded secrets somewhere that aren't encrypted. Lots of people have access to that shouldn't, and see all the goals. One of the best tools to get started with if you need to get secrets out of being hard-coded is a Mozilla tool called SOPs, or Secret Operations. And it's a tool that'll work with pretty much anything, because it's just a little command line tool that lets you encrypt your secrets and then you can put them in source code, which makes some people cringe, but it does work. It's a heck of a lot better than having hard-coded secrets. And it lets you limit who has access to your secrets to just the server that's going to run the code. So your developers can still change the secrets using the public key, but they'll never see the secrets. They're never able to decrypt them again. It's a pretty cool little tool. Then there's all of the platform integrated solutions. So if you're on Google, Google Cloud has Secrets Manager. AWS has Secrets Manager. Azure called it Key Vault instead to be different. And they work really well. They often integrate with all of the other things. So if you're using managed database, if you're using any of the other services that cloud offers, they often do all of that stuff around automated rotation of keys and all of that sort of stuff. Shout out to AWS Parameter Store as well, because Secrets Manager can be quite expensive. And so if you've got a small application that you're running, actually Secrets Manager can add to the bill quite significantly if you're using all the features. Parameter Store will get you most of the way there. Maybe you need to do some manual rotation and stuff, but it's a lot cheaper. So that's also a consideration. And then we move into the more heavy hitters. Full disclosure, I do a lot of work with HashiCorp Vault at the moment. But generally, that gets deployed when you have multiple clouds, or you have stuff on premise and stuff in multiple clouds and stuff spread around the globe, and you want something that's able to put it all in one place. It also usually has a bit more of a maintenance overhead. You kind of need someone to look after it. Whereas with the cloud services or SOPs, once it's there, it just works. So, and then finally, the end goal is this new thing. I think it's new. I don't know. I only learned about it this year, called workload identity. And if you're in a cloud and you're just doing in one cloud, you're probably already doing it, which is that your workloads have an identity token of some description that they get somehow. And then they can use that to go to the database and say, hey, I'm me. And the database says, you're you can talk to me, rather than them having to go and retrieve a password to talk to that database from somewhere. And so at that end of the spectrum, you no longer need to manage secrets, because that token's short-lived. Your application or your server automatically knows how to get a new one. But yeah, it's tricky. There's a bit more work to set up, but that's the end goal, is that we don't do secrets management anymore, because we don't really have to. Cool. Final thing that I wanted to discuss, which I sort of play more in the DevOpsy, infrastructure-y space, and often the bit that gets left out is how it looks as a developer when you start introducing some of these secrets management things, and you start talking about rotating database credentials on a regular basis. And yeah, so what happens with the application? Normally that has to change at least a little bit, depending on how you're running things. So there's two main things that I want to discuss. One is when the application starts up, and the other one is when you rotate secrets, because there's some considerations with both of those. So generally, when I start writing a script, first thing I do is hard code like just put the API key like in the code and hit run, and it talks to the API and I get a response back, and I'm like, sweet, it works. And then before I commit it to Git, that's the important part. Actually, you shouldn't do this in the first place, but if you do, before you commit it to Git, generally what you do is you end up putting it in an environment variable somewhere, so it's not in your source code anymore, right? And for a lot of applications, that's where it ends. And then you have some config files that change the environment variables depending on which server you're on or whatever. And that's sort of that's how a lot of applications run these days. The thing is that there's a couple of things with that. One is that there's a lot more instances these days of attacks where people are able to enumerate all the environment variables, and not necessarily from the outside, but also if you have like multi-tenanted Kubernetes clusters or AWS, like with Lambda functions, sometimes people don't realize that if you don't set them right, a developer can see all of the environment variables of all the Lambda functions. So if you have your database password in there, it's readable. So while a lot of the advice still says the safest way to do things is to put your secrets in environment variables, actually now there's often better ways of doing things. And putting the secret on disk, but not like a disk, like a in-memory disk, or having the application start up, reach out to the secrets management engine, pull it into memory, and you never have it in an environment variable in the first place, is often a better approach. Because if it's not in an environment variable, you can't see it. So generally on application startup, there's two steps. The first one is you have to obtain the secret somehow, which might be that you go and retrieve it from a secret store, or it comes in from a as an environment variable, or you load it up from disk. So for example, I've been doing some work with Vault, and we have some consumers that are in Kubernetes, and so it automatically gets mounted as a file. So when the application starts up, it reads the file, load it into memory, and then finally, hopefully, if it is something that you control, you can actually delete the file on disk. So now the only place that it is in is memory, and it's only going to show up on disk again. It's not a disk. Sometimes it's it only shows up again if your application restarts, at which point, as soon as it restarts, it loads it in from disk and deletes the file on disk. So the only place it is in memory, and it's a lot harder for attackers, at least at the moment, it seems, to enumerate the variables that you have in memory than it is to look at your environment variables or look at files on disk. The other part is secret rotation. And so you have two options, basically. And again, secrets aren't just database credentials, but it's usually the example. You have two ways to rotate database credentials. You can use a single user, or you can use multiple users. And often, especially from the application point of view, you have to think about what's going to happen between your application and the database or whatever it is you're talking to when that secret changes. So I looked this up earlier today because, to be honest, I didn't really have a clue. Most databases, when you change the password on a user, they don't let you query the database anymore. Some of them will disconnect your session. Most of them will stop you querying. Postgres, on the other hand, lets you keep querying away on the same connection. It's only when you try and stand up a new connection that it doesn't accept the old password anymore. So depending on what the database that you're using or what it is you're talking to, depends on when the application is going to go, my secrets don't work anymore. At which point, either your application needs to restart somehow, needs to know to restart, or it needs to know that it needs to try and get new credentials. And it's often what I've seen is, the platform engineers are all like, yeah, we got this new secrets management system and we can rotate them on an hourly basis, and the application does not want to have a bar of that, and they have to make changes. So this is where dual user rotation comes in. So basically you have two database users, you change the password on one, then you go and tell the application about it, wait until all the applications restart, and then you go and disable the old user. And then the next time you want to rotate, spin up a new user, change, tell the application about the new user, wait for it to rotate, then disable the old user, which is, if you've automated it, not a lot of work. If you haven't automated it, more work, but your application doesn't crash in the middle of you trying to rotate it. If you accidentally change the password and then go to lunch, application might not be running when you get back. So yeah, that's sort of some of the considerations that happen at the application level that often don't get talked about in the infrastructure side of things. Yeah, that's going to change slides. That's pretty much it. So I highly recommend looking at the secrets management cheat sheet if you want to know more about secrets management, and all of the other cheat sheets, because there's hundreds of them, literally. Mozilla SOPs, if you're after something lightweight and easy to manage secrets, whatever's built into your platform is probably going to do a pretty good job of managing your secrets. And then if you're multi-cloud, multi-data center, lots of stuff, HashiCorp Vault, or there's other paid-for Vault things, secrets vaults, that do the same thing. And then last one is workload identity, where that's the open source one. There's other implementations of workload identity depending on where your stuff's running. And the last one is the article about why environment variables aren't always the best place to store your secrets. And the QR code takes you to the slide, so you don't have to write down the names of the things. You can just click the links when. Cool, that's me.
Oh, thank you.